geobyte.
Look at the another question. It is asked like this. It is asked like this. Match list 1 with list 2. Torque, magnetic field, magnetic moment, permittivity of free space. So these are under list 1. Under list 2, dimensional formulas. Different dimensional formulas. For that, first let us decide the dimensional formula for the torque. You know, torque torque generally denoted with tau is equal to force multiplied by perpendicular distance. Perpendicular distance. Force is in Newton, distance is in meter. Newton meter. Newton meter is the unit of joule. So the torque unit is joule. Joule is the unit of energy. Therefore, the torque unit, energy unit both are same. Torque unit and energy unit both are same. The torque dimensional formula is equal to energy dimensional formula because torque unit is joule. Energy dimensional formula ml square t power minus 2. So that is the dimensional formula for torque. ml square t power minus 2. ml square t power minus 2. ml square t power minus 2. So A4 correct. A4 correct. So A3 first one is not correct. Last one also not correct. So A4. Option may be either B or C. Right? Then right 50% of answer is known. Then look at the magnetic moment. Magnetic moment. Magnetic moment dimensional formula AL square. AL square. Therefore, C2 correct. C2, C3 given. So B not correct. C2 correct. So option C is absolutely correct. Like that, you can save the time, right? By knowing the dimensional formula for one or two quantities. From the torque dimensional formula, 50% of the answer you got it. You know the magnetic moment is in L square a power, L square means L power 2 a power 1. Therefore, the A4 correct, C2 correct. So A4, C2, right, are matching with the only option C. Option C is correct. Understood clearly? Yes. Look at the another question. It is asking like this. Try to read it clearly. What is the dimensional formula of a b power minus 1? A b power minus 1 dimensional formula is asking. In the equation p plus a by v square into v minus b equal to rt, where letters have their usual meanings. Look at the equation consists of two quantities mainly. One quantity is p plus a by v square, and another quantity is v minus b. Since a by v square is adding with the p, therefore I can say that a by v square unit must be p unit means pressure unit. P unit. The p be the pressure, v be the volume. Similarly, here b is subtracting from the v. Therefore, b unit, b unit, b unit must be volume v unit. Here v is the volume, p is the pressure. Okay. Now here the pressure unit is Newton per meter square. Okay. Therefore, A by V square unit must be equal to Newton per meter square. Now let us write the dimensional formula for A by V square. Dimensional formula for A by V square must be equal to pressure dimensional formula. Pressure equal to what? Force per unit area. Force per unit area. Here force dimensional formula M L T power minus 2 dividing by area L power 2. L power 2. Simplify this part. It is M L power minus 1 T power minus 2. This is the dimensional formula for A by V square. Let us take another slide. Here we got A by V square. Here V is the volume. Volume dimensional formula L cube whole square. L cube whole square means directly I can write L power 6. L power 6 must be equal to what? Must be equal to M L power minus 1 T power minus 2. M L power minus 1 T power minus 2. From this, the A dimensional formula is M power 1 L power 5 T power minus 2. That is the A dimensional formula. Similarly, let us decide for the B. Here, V minus B is another quantity. Therefore, the B dimensional formula must be equal to volume dimensional formula. Volume L power 3. Then, you are asked to decide A B power minus 1. A B power minus 1. A M L power 5. L power 5. T power T power T power minus 2. T power minus 2. This is the B dimensional formula. B power minus 1 dimensional formula is L power minus 3. L power minus 3. L power minus 3. It is M L power 2 T power minus 2. This is the dimensional formula for A B power minus 1. I hope all of you clearly understood. Now look at the options. M L power 2 T power minus 2. Option C is absolutely correct. Understood clearly? Yes. Then look at the another question. It is asking like this. If G be the gravitational constant and U be the energy density, then which of the following quantity have the dimensions as that of root over UG? Here G is the gravitational constant, U is the energy density. Energy density means energy per unit volume. First let me decide the dimensional formula for root over UG. For that, let us take the gravity force equal to G m1 m2 by r square. From this G equal to F r square by m1 m2. Let us write the dimensional formula for G. G F m L T power minus 2 T power minus 2 L square. Listen carefully. Dividing by m power 2. It is m power minus 1 L power 3 T power minus 2. So this is the dimensional formula for G. The next quantity is energy density. energy density means energy density U equal to energy per unit volume. Energy dividing by volume. Energy dimensional formula. So U dimensional formula energy M L square T power minus 2. This is the dimensional formula for energy L power 3. L power 3. So U dimensional formula is M L power minus 1 T power minus 2. Then UG. First let me write for UG. U M L power minus 1 T power minus 2 T power minus 2 G M in M power minus 1 L power 3 T power minus 2 M power minus 1 L power 3 T power minus 2. So it is equal to M power 0 L power 2 T power minus 4. This is the UG dimensional form, but he is asking root over UG dimensional form. Root over UG dimensional formula. Here it is L power 1 T power minus 2. This is the UG dimensional formula. Understood clearly? Yes. Now, among the given options, which quantity is maintaining the same dimensional formula? First, let us take the pressure gradient per unit mass. Here, dP by dx is a pressure gradient. First, let us decide the dimensional formula for pressure gradient. Here, dP, dP is in Newton per meter square, dx is in meter. So, dP by dx unit is Newton per meter cube. Then the dimensional formula for dP by dx. After finding the dimensional formula for pressure gradient, then you can find for the dimensional formula pressure gradient for unit mass. Here Newton is the unit of force. Force dimensional formula ml T power minus 2 dividing by L power 3 is equal to m L power minus 2 T power minus 2. That is the pressure gradient dimensional formula. He is asking pressure gradient per unit mass. dP by dx per unit mass. Unit mass. Dimensional formula. Here dP by dx we got m L power minus 2 T power minus 2 m L power minus 2 T power minus 2, right, minus 2. Then the dP by dx dividing by mass equal to m L power minus 2 T power minus 2. Is it correct? Correct. Dividing by m. Simplify this part. Simplify it. So it is L power minus 2 T power minus 2. So this is the pressure gradient per unit mass dimensional formula. Is it same? No, it is L power 1 T power minus 2. Therefore, option A is not correct. Okay. Similarly, look at the gravitational potential. Gravitational potential. Dear friends, remember gravitational potential. Let me write it. Gravitational gravitational potential is equal to negative sign of work per unit mass, right? Work is a kind of energy. Indirectly, it's dimensional formula, energy dimensional formula dividing by mass dimensional formula. Therefore, gravitational potential generally denoted with V. Here V is not volume. V, right? Dimensional form energy M L power 2 T power minus 2 dividing by work is a kind of energy, mass. So here it is, M is cancelling, L power 2 T power minus 2. But the no root over UG L T power minus 2, whereas we got L power 2 T power minus 2. Therefore, the B also not correct. Okay, are you following? Yes. Similarly, energy per unit mass. Here gravitational potential unit is energy per unit mass only. Therefore, the energy per unit mass dimensional formula and gravitational potential dimensional formula both are correct. Both are same. Both are same. Therefore, B and C are not correct. Now look at the force per unit mass. Force per unit mass. Force dimensional formula dividing by mass dimensional formula. Force ml t power minus 2 dividing by m. Now you simplify it. For getting L t power minus 2, it is L power 1 t power minus 2. That is the dimensional formula for force per unit mass. L power 1 t power minus 2. L power 1 t power minus 2. Therefore, the force per unit mass dimensional formula is equal to root over UG. Option D is absolutely correct. Understood clearly? Yes.
Geobyte.